we have a relationship between the permutation and combination. That is, NPR is equal to NCR into R factorial. So clearly 10C2 is same as 10C8. That is, selection of 2 objects is nothing but rejecting 8 objects. So when you have N and R as same, it is nothing but 1. Also you may take 5C0 is 1, 17C0 is 1. So when you have NC0 form, the value of the combination is directly 1. No need to evaluate using the formula. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we will be studying about the combination. In our previous session, we have learned how to arrange an object or a thing or numbers or letters using permutation, where order matters and combination is nothing but an arrangement of only the selected objects, but here order does not matter. So let's see what is combinations now. So for a combinations, we have a formula using NCR. So we denote the selection of R objects out of N objects using NCR, whereas permutation is denoted by NPR. Next, we have in a combination, order is not important. So here the order is not important. Suppose we have to tell that AB has to sit together. So AB has to sit together, then it is one arrangement. BA is also another arrangement. So this is permutation. But we say AB has to sit together, that is only the combination. So whether they sit in the form AB or BA, the selection is only 1. So this is nothing but the combination. So these, if you consider AB as one arrangement, BA as another arrangement, then it is permutation. But only if we are supposed to tell that AB has to sit together, that means they can occupy any of the places. Their places may be interchanged, but it is only one arrangement, that is the combination. So therefore here the order of the objects or numbers or letters does not matters. Next, we have a relationship between the permutation and combination, that is NPR is equal to NCR into R factorial. So here R is clearly less than or equal to N. So you may select all objects from the N objects. So therefore R may be equal to N also. So therefore it can be, read it as NCR into R factorial is equal to NPR. R factorial, when you have any values like 3, 7, 5, then it is multiples of all the numbers from 1 to the given number. The formula of NCR is given by N factorial by R factorial in N minus R factorial. So actually this N factorial by N minus R factorial is your NPR. So we have here NCR is equal to NPR by R factorial. So therefore we arised a relation, that is NPR is equal to NCR into R factorial. So this is the relationship between the permutation and combination. So here this is the formula for the combinations. Next we have NCN is equal to 1. NC0 is equal to 1. So if you substitute N in the place of R here, it becomes N minus N, 0 factorial. N factorial cancels. So the value will give rise to 1. NC0. If you put R is equal to 0 there, then again it is N factorial over N factorial, which get cancels and you will get 1. So you also can write one more relation, that is NC1 is equal to N, and also NC N minus 1 is also N. So you can get the examples as NC1 is equal to N. If you put R is equal to 1 there, it is 1 factorial again. So here you are left with N minus 1 factorial. So you will get N. Similarly, N minus 1, if you substitute here, it is again N only, because in the place of R you have N minus 1 factorial. All the terms of N into N minus 1 into N minus 2 cancels until N minus 1. You are left with only N. So you can take examples as, suppose you have 5C1, then it is 5. also 5C4 is also 5. So this arises to one more case in the next here. So you can see NC n minus R is equal to NCR. They are one and the same. So NC n minus R can be written as NCR. What is the meaning of that? Selecting OR object is nothing but rejecting n minus OR object. So if you are selecting OR objects from n, the remaining are n minus R, which you are rejecting, which are one and the same. So therefore, the combination of n minus R is same as NCR. Next, we come across one more case, that is, suppose NCA is equal to NCB, then either A is equal to B or N is equal to A plus B. You can take this as an example. Here you have, this is in the form of NCA, NCB. N is same, that is 5, A, B are different. So it is 1 and 4. So what is N then? It is A plus B. So what is 1 plus 4? It is 5. So if two combinations are equal, either the R term is same or the sum of the two terms will be equal to the value of N. So you can take this as an example also. So now based on these results, we can take few examples. NCN is equal to 1 means we can take 7C7. If you get any term like this, it is nothing but 1, or 20C20, it is also nothing but 1. So when you have N and R as same, it is nothing but 1. Also you may take 5C0 is 1, 17C0 is 1. So when you have NC0 form, the value of the combination is directly 1. No need to evaluate using the formula. You can take the examples of this also. If you have 10C6, so 10C6 means this is equal to 10C4. So you can clearly say if this is R, then this is N minus R, that is 10 minus 4. So this is in the form of 10 minus 4. So therefore 10C6 is equal to 10C4. So we arise this case again here. We have same NCA is equal to NCB and N is equal to A plus B. 6 plus 4 is equal to 10. So for example, 15C7 is equal to 15C8. So you can clearly say 7 plus 8 is equal to 15. Or when you arise a case like NC2 is equal to NC8. What is the value of N here? N may be sum of two numbers. So 2 plus 8, which is equal to 10. So clearly 10C2 is same as 10C8. That is, selection of two object is nothing but rejecting 8 object. So therefore the formula for the combination for the both, the value will be same. Next we come across a statement NCR plus NCR minus 1 is equal to N plus 1 CR. So let's see here now what is NCR. It is N factorial, R factorial, N minus R factorial. Next NCR minus 1, N factorial. In the place of R you have R minus 1 factorial. And here you get it as N minus R plus 1 factorial. If you substitute R minus 1 here, minus into minus 1 becomes plus 1. And this is equal to now. Again. So we are taking only the left hand side part here. Now, N factorial. R factorial can be written as R into R minus 1 factorial. Because 3 can be written as 3 into 2 factorial. Similarly, N factorial can be written as N into N minus 1 factorial. So the same condition here we are applying for R. Next here, R minus 1 factorial. This can be written as N minus R plus 1, N minus R plus 1 minus 1 becomes 0. So we are left with N minus R factorial. What are the common factors in those two? One is N factorial, another one is R minus 1 factorial, another one is N minus R factorial. So you are left with 1 by R plus 1 by N minus R plus 1. So when you solve this, here you will get this as N minus R plus 1 plus R divided by N minus R plus 1 into R. So minus R plus R get cancelled. N factorial into N plus 1. For example, 3 factorial into 4 can be written as 4 factorial. In the same way here, I can write this as n plus 1 factorial. Again we have r minus 1 into r, which is r factorial. N minus r into n minus r plus 1 can be written as n minus r plus 1 factorial. If you rearrange this properly, you will get n plus 1 factorial by r factorial, n plus 1 minus r factorial. Now this is in the form of n factorial, r factorial, n minus r factorial, which is nothing but ncr. But what is n here? N plus 1 cr. So which is the right hand side of the result. Hence we have proved it. Second question, NC8 is equal to NC2, find NC2. So here we have the case of NCA is equal to NCB. If two combinations are equal, either A is equal to B, but A is equal to B is not possible. Then only the next case is N is equal to A plus B. So therefore, here according to this, N is equal to 8 plus 2, which is nothing but 10. Now we need to find out NC2. NC2 means 10C2. What is 10C2? 10 factorial, 10 minus 2 factorial into 2 factorial. 10 factorial, 8 factorial, 2 factorial. We can write this as 10 into 9 into 8 factorial over 8 factorial into 2 factorial can be written as 2. So we can cancel all the terms from 1 to 8, which is nothing but 8 factorial. 90 again 2 ones are 2 5s are. So the answer is 45. So the value of NC2, that is 10C2, is 45. Next we have determine NC17 if NC9 is equal to NC8. We need to find out NC17. So here, according to the given condition, this implies n is equal to 9 plus 8, which is 17. So therefore, NC17 is nothing but 17C17. What is the value of NCN? It is 1. So therefore, the value of this is 1. So no need of substitution. You can directly remember all those points and substitute the value as 1. Next one, how many chords can be drawn through 21 points on a circle? Okay, suppose we have a circle here. So we may have 21 points on the circle. What is the minimum number of points required to draw a chord? Only 2. We need only 2 points. But we have total 21 points on the circle. Minimum points to draw a chord is 2. So how many ways or how many chords we can draw inside the circle? That is, so number of chords is equal to 21C2. Because we have 21 points. So therefore 21C2. Now how we'll write 21C2? 21 factorial, 2 factorial, 21 minus 2 factorial. 21 into 20 into 19 factorial I'll write. 2 factorial is nothing but 2. 21 minus 2 is 19 factorial. I can cancel 19 factorial. 2 ones are 2 tens are. So 210. So like this, we can join all the 21 points to construct a chord inside the circle. So how many chords can be drawn? 210 chords can be drawn. So the same condition is applied for a regular polygon. So for a regular polygon, so number of diagonals you can draw is NC2, which is same as NC2. For example, for a pentagon, you have 5 vertices. So how many diagonals you can draw inside the pentagon? 5C2. So you can verify by constructing also. For a hexagon, it becomes 6C2. For a decagon, it becomes 10C2. So like this, it is same for constructing a chord with given number of points inside the circle, and for a polygon, it is drawing diagonals which are one and the same, because diagonal is nothing but a straight line which require only 2 points. Well, any polygons have n number of points, so therefore it can be replaced with the formula NC2. Next we have, in how many ways can a team of 3 boys and 3 girls can be selected from 5 boys and 4 girls? So, we have 5 boys and 4 girls. We need to select 3 boys and 3 girls. So, remember, in a combination, and is nothing but multiplication, or is nothing but addition. When it comes to an arrangement, the statement and is nothing but multiplication, or is nothing but addition. So therefore here, number of ways I can choose or I can select both the boys and girls in a way such that we have 5 boys, out of them we need to choose only 3 boys, and we have 4 girls, out of them we need to choose only 3 girls. Now 5C3, 5 factorial, 3 factorial, 5 minus 3 factorial. Here 4C3 can be directly write as 4. I have given an example. NC n minus 1 form is nothing but n. So it is 4, 4 minus 1, which is 4C3. The value will be equal to 4 only. Now here it is 5 into 4 into 3 factorial by 3 factorial into 2 factorial. So 3 get cancelled. 2 factorial is nothing but 2. 2's are. So here it is 10 into 4 into 4. So total 40. So you have 40 ways of choosing any 3 boys and any 3 girls out of 5 boys and 4 girls. We'll meet you in the next session with few more problems on the combinations. Until then, keep watching, keep learning and keep exploring. Thank you.